I'm Dr. T and welcome to my office. So today I'd like to talk about what happens when water dissolves stuff. So in this case we're talking an aqueous solution. And obviously we can think about the solute that water is dissolving as one of two categories, ionic or molecular. And so if it's an ionic compound, then water is going to surround the ions, separate them from the lattice, assuming it's able to. If it's not able to, then the lattice is just going to sit there. It's going to separate them from the lattice and they will float around free. This has a couple of interesting consequences. For starters, if I have a solution of, let's say, sodium chloride, I don't really have aqueous sodium chloride. I have sodium and chloride. They have been separated. When we discuss chemical reactivities, it's sometimes actually more useful to think about the individual ions in solution than their parent compounds. The second consequence is that because these are ions, they have a charge. And, well, things with charge that can move can conduct electricity. Therefore, if you have charged ions, you're going to call these an electrolyte. Yay, that's really all that what we're saying Gatorade has when it says it has electrolytes. It's got ions, specifically sodium, potassium, ones that your nerves are going to use for sending electric signals because, once again, electricity. Now, if we're dissolving a molecular compound instead, molecules don't have a charge. Molecules with a charge are known as polyatomic ions, and those would be ionic compounds. But good old molecular compounds don't have a charge. So when those are dissolved, no charge. These are non-electrolytes. Now, of course, nature doesn't confine to our nice, neat boxes, and will do some interesting stuff. So when we talk about electrolytes, we typically actually talk about two different types of electrolytes. What we call strong electrolytes, which are material that break up basically just as I described. They're either an ionic compound or there's a couple of molecular compounds that kind of on the border. Things like hydrochloric acid, where while it's a molecular compound, once it hits water, the hydrogen splits off as a cation and the chlorine as an anion. Go figure. So these would be referred to as strong electrolytes. Once they're dissolved, they are split apart. They're no longer together. However, there are some molecular compounds that will sometimes split apart, but not always. A classic example would be acetic acid, aka vinegar. In this case, some of the acetic acid is going to split apart into acetate, which is a polyatomic anion, as well as an H+, which will be piggybacking on the back of a water molecule. However, not all of them, and some of them will stay together as an acetic acid with the acetate part and the hydrogen still stuck together with a covalent bond. Because of this, we call these a weak electrolyte. And if these weak electrolytes are acids, we'll call them weak acids, and strong acids would be a strong electrolyte that is also an acid, also capable of giving up an H+. So yeah, that's a brief introduction to what's actually happening when you dissolve stuff, and it is definitely important to keep in mind with those ionic compounds that once they're dissolved, the ions are separate, so each ion ends up becoming the active party for any particular chemical reactions. So with that said, have a wonderful day, and I'll see you in later videos.